No, we gotta go. You can tough it out for a minute.
John, come right here.
I know.
Okay, you guys ready?
Right here.
Okay.
I know it.
How does a swing work?
Please.
Hey, shush. How does a swing work? As a pendulum rises, its kinetic energy changes to potential energy, and as it falls, the potential energy changes back to kinetic. The only way to increase the height of the swing is to increase the total energy of the pendulum. A pendulum is a weight suspended from a pivot so that it can swing freely.
Where is the energy coming from to pump up a swing? You normally only change position at the end of the path when you're at the top of the arc and momentarily stationary energy is force times distance. And an impulse at zero velocity transfers no energy. The only place you can expect to find energy would be gravity. At the end of the arc, when you change positions, you lift yourself slightly, and that increases your potential energy at the moment when your kinetic energy is least.
Where's the lift coming from? At the peak of the backswing, the head and the body go back, and your legs go forward. And at the front, your head and your body go forward, the legs go back. One might speculate that this motion represents a rotation. If you sit in a slightly moving swing and just tilt your head back and forth in the usual rhythm while keeping your legs and body rigid, the swing will respond. But if you keep your head and body rigid and just swing your lower legs back and forth in the usual rhythm, the swing will respond.
A line of pole. A line of pole is not through your center of mass. It is at the bottom of the arc. At the top of the arc, when you're going forward, your body is also rotating. From the right, you are rotating counterclockwise. If you're going backward, you're rotating clockwise, and you have got negative angular momentum, which is conserved.
What if you go over the bar? You can't go over the bar. As soon as the arc reaches 180 degrees, which is as far as it can go, the pull of the chain no longer has a vertical component at the peaks of the arc. The pumping will stop working. There's no way to pull yourself up, and if the chain points down. Your velocity vector as you peak the peak of the arc on the backswing is actually pointing forward, and your velocity vector, once you pass the horizontal in front, is pointing backward. You won't come back down a nice clean arc. You will come back down falling.
Our measurements: height was 6 foot, 27 inches, length 11 feet, 8 inches. The swing was a low belt constructed of the full person. It is held down in the ground for a year, so it will not tip over while you're swinging. And we drew this, and we measured there, and there, and that. And then here's some pictures we took.
Our simple machines, it's a second-class lever. A lever is a type of simple machine that is used to lift weights. The swing chains connect to the fulcrum, which is the top of the bar. The top of the bar is located at one end, while the input effort is at the other end of the bar. It means that the top of the bar and the input are opposite to each other, and the output load lies at a point between these two forces. The mass is more than one in all the cases where this type of lever is used.
Here's some pictures. This is
Any questions?
What, laddie?
Simple machine.
what?
Discuss simple.
Second class lever.
Yeah. Any other questions? So sixth graders, how does a swing work?
By pumping your legs, pumping your chest, moving your body.
Yeah, moving your body back and forth.
And why did
Which one does more good? Moving your legs or moving your chest?
moving your legs?
Both?
Yeah.
I think maybe you should try that out at lunchtime too and find out. Can Can you swing better with your legs holding still or with your upper body holding still? You might want to try that out.
What interesting fact that did these girls give us about the swing that in elementary school, I think every one of us tried to do?
Jump out?
Go above the bar.
Go above the bar, going over.
I still
Why
try.
can't we do that? What did they say? Why can't we do that?
You said 180 degrees, right? Yeah. Where's the 180 degrees? This ends up being what compared to the ground? Parallel. Good job. If I let go of this, is it going to go back that way and swing through? What happened the second time? It went up and it stopped and it dropped. So if we push this and let go up here, it flops when it falls too. But if you pull it and you keep this straight, then it'll swing right. But when it gets back there, it won't because of the gravity. It's only doing it because when it comes up, that's why you can't go over the top, because gravity pulls straight down and the swing, the chain, can't pull this way after you get above it. It can't pull down and over here because gravity's going to pull you straight down here, and then the chain will get tight here, and then it'll swing normal from there, but that's going to be a jerk right there that's probably going to throw you out of the swing.
The force on that swing can get you up, but after so much, it can't get you.
So, I still have one question. If you're going to make that swing go all the way around, the swing has to go in a circle, right?
Yep.
Yeah.
Can forces go in a circle?
No?
Yeah.
Forces go in a circle?
If I take my keys, can I make my keys go in a circle by applying a force? What happens if I go really fast? Do they continue to go in a circle after they slide off my hand?
Yeah.
No. When they left my hand, which direction did they go?
That way.
Was that straight or curved?
Straight.
So can forces be in a curve? No, all forces are in a straight line. So how do you make your car go around a corner? That's a curve, right? Is it only one force that makes your car turn around a curve? Or is it a whole bunch of different forces at different angles? There you go. When you were little, did your dad grab both your hands and swing you around until your feet came off the ground?
Yes.
Is he applying one force to you, or is he applying a different force every second?
Different force every second.
Is that force in a different direction or the same direction?
Different.
That's how you get curves. A whole bunch of forces in different directions. What else you got? Upperclassmen, did we miss anything? They covered everything on the rubric? Do you have questions? Well, we need to know if the kids understand. That's in the rubric. Did they do a good job helping you understand it?
Yeah.
All right. I think we better let them off the hook.